Unlock your future in the world of technology. Welcome to Medha XL, the land of IT. Our goal is straightforward, but the mechanics are precise. We are going to take a user's raw text and flip it in perfect reverse. Look at this dark mode interface to see the final application in action. We type in the phrase, "Hello World," and the inverse, WROWLLEH, is instantly returning to the screen. You will see this specific challenge routinely in technical interviews. It is a standard hurdle because it requires you to prove you can navigate character arrays and execute logic loops without breaking the application. To build this, you need two standard tools: a functional Java development kit installed on your machine, and an active integrated development environment, or IDE, to write the code. Completing this algorithm demonstrates the three core stages of a basic program: capturing an input, storing it in a variable, and then reordering that data through index manipulation. Here is our starting blueprint: class reverse string and an empty main method block. Notice the yellow highlight on line 1. This import statement pulls in the scanner utility, required to detect keyboard input. Inside the main method, we initialize our scanner object. This tells the application to actively listen to the system's input stream for incoming keystrokes. Next, we write a standard print statement to prompt the user. This simply asks them to provide the text they want us to reverse. When the user hits enter, the scanner captures those keystrokes. We immediately assign that data to a newly declared string variable, locking it into the system's memory. At this stage, check your syntax. If you don't see any red error indicators under your scanner declaration, your setup is structurally sound. We now have a functional communication channel. The application can receive and hold the user's data, but it currently lacks the logic to actually modify it. Look at the new variable added to our IDE. We declare string reversed and set it to an empty set of quotation marks. This is our holding container, where we will build the new word one character at a time. To populate that container, we build a descending for loop. This structure forces the program to read the captured text backward. The condition parameters highlighted here contain a frequent failure point. If you forget to subtract 1 from the total length, the compiler attempts to access a non-existent character, causing an error. This schematic explains why. Computer indices begin counting at 0. In a 5-letter word, the final letter sits at position 4. Subtracting 1 from the total length ensures we start correctly. Inside the loop, the action is repetitive. We extract the character at the current descending index and append it directly to our empty holding string. Keep in mind that strict case sensitivity applies to all Java syntax and variables. A mismatched capital letter in your variable names will prevent the code from compiling. This loop systematically reads the original input from end to beginning, copying the characters into a new sequence, while leaving the source data intact. With the reversal complete, we must step completely outside the for loop's closing bracket before taking our final execution actions. As you can see underneath the closed bracket, we instruct the program to print out the fully assembled reversed string directly to the console. Finally, look at the absolute bottom of the method block. We call scanner.close. This is a best practice used to prevent memory leaks and free up system resources. Closing the scanner is a final step in managing the program's lifecycle, ensuring that system resources are released once the output is delivered. Now initiate the compilation and execution sequence. You can use your IDE keyboard shortcuts like Shift plus F10 to run the code. Look at the active console in the bottom 30% of the screen. We enter the phrase instructional design and verify that the console returns the characters in the exact inverse order. Next, we run a second operational test, this time using a perfectly symmetrical word, like race car. The output is identical to the input, proving the loop handles palindromes correctly. Your string reversal blueprint is functional. The next step is to modify this logic with a conditional check to create an automated palindrome detector.